Hi, my name is Cordero, and I am going to present you our study that is entitled The Role of Acoustic and Contextual Cues for Lexical Disambiguation in French. In contrast to written language, that beginnings and ends of words are unambiguously marked, spoken language lacks any clear cue associated with word boundaries. There is a vast amount of literature showing how listeners use their tacit knowledge in their native language to achieve speech segmentation. But often we are exposed to transient ambiguities, such as the French sequence l'abricot, the apricot, that can be compatible with several options, such as the ones here. Such situations give rise to what is called lexical competition, which is a process that allows listeners to sort out ambiguities and recognize the target meaning. However, this process is not as simple when listeners face phonemically identical sequences such as l'ami, that has a similar phonemical representation but has two different meanings, the cram and the friend. Several acoustic patterns have been evidenced to be used as cues to segment continuous speech, and for this study we have focused on the rise of the fundamental frequency that often appears in the first vowel of content words. A previous MMN study showed that French listeners were able to differentiate both homophonic sequences, and this suggests that top-down processes are involved in the process of recognition of lexical items. Therefore, in our study, we wanted to observe to what extent the system's sensitivity to fine-grained acoustic details might change when presenting listeners with semantically congruent sentences containing incongruent acoustic cues. For that, we recorded sentences containing our homophonic pairs, such as the ones here, and we cross-spliced the homophones for half of the sentences to create incongruent sentences. We performed repeated measures ANOVA with three factors: condition, laterality, and spatial dominance, each with 3 levels, and we corrected for sphericity. Our statistically significant results were tested in post-hoc tests using the Bonferroni correction, and to avoid reducing the statistical power of our data and correct for multiple comparisons, we performed a permutation analysis to find our time window with significant effects and reveal the presence of an N400-like component peaking at 315 milliseconds to 348 milliseconds. Our tests showed no significant differences between our experimental conditions, but control was statistically different from both congruent and incongruent sentences. The topographical distribution showed that frontal and central brain areas were more positive than parietal, and right and midline were more negative than left brain areas. Our topographic maps and the ERP averages confirm this. In the left ERP waveform, we have a central right electrode, the C2, where there is a significant difference around 400 milliseconds, and where the control condition is more negative compared to the both congruent and incongruent conditions. And the right image shows that there is no significant differences between the conditions in the frontocentral electrode FCZ. So our results give further evidence that listeners processed semantic violations that were present in our controlled sentences. Moreover, during our passive listening paradigm, listeners did not process congruent and incongruent sentences differently, and this suggests that fine-grained acoustic information is not used as a cue when exposed to an informative enough context. Thus, top-down processes are involved in passive sentence comprehension with ambiguous lexical items. Thank you very much.